Example 6. A sodium light of wavelength 580 nanometers shines through a slit and produces a diffraction pattern on a screen 0.6 meter away. Let me just draw the situation. So through a slit, so there's only a single slit, and then on a screen 0.6 meter away, so this is the screen. So this distance is berapa? Dia tidak bagi. So this is A, and then this is the distance, which is 0.6 meter. And then what else? The width of the central maximum fringe on the screen is 5 centimeter. Okay, so the width of the central maximum fringe is 5 centimeter. That is y1 equal to 5 centimeter. Okay, so we have to calculate the width of the slit. So remember, W, which is the width of the slit, is given as 2y1, and y1 is already in the question. So you just have to the width, astaga, the width of the central maximum. Sorry, that is confusing. I'm not confused, I'm just tired, I guess. Let me do this on a paper here lah, sebab macam tidak space. So given is lambda, which is the wavelength, and then given also is the distance from the slit to the screen, which is 0.6 meter, and then the width of the central maximum is 5 centimeter. Okay, so the width of the slit is given as 2y1, where y1 is given as lambda d over a. So substitute that. Okay, so from here you will get the width of the slit to be equal to 1.39 times 10 negative 5 meter. Okay, and then question B, we have to calculate the angular width of the central maximum fringe. That is, angular width is that one, and then you know that this is the equation where the first angular width is this equation here. Okay, so this is all in my notes, in our notes. You just have to apply the equation. Okay, so from here you will then get 4.78 degree as the angular width of the central maximum fringe. Okay, and then question C, dia suruh kita buat calculate the number of minimums that can be observed on the screen. Okay, number of minimum, we have to apply the equation for minimum fringe is sine theta equal to n lambda. Okay, so we know that for the maximum number of order for minimum fringe, we have to take theta to be equal to 90 degree, right? So we are gonna use 90 degree. So 1.39 is the width slit. So sine 90 degree, and is, look, we are looking for the maximum number of minimums that can be observed. So wavelength is 580. So you will get the number of minimum that can be observed. This is the maximum slit. The maximum number of fringes. So around this approximately 23. So because we have positive and negative fringe, we will multiply this with 2 lah. So 23 times 2, we have 46 fringes can be seen on the screen lah. Okay, alright, that is example number 6.